try.
Ladies and gentlemen, are you ready?
Okay, so it all makes things better with the music, so I think now we are all ready to fight. So the fight of today will be, well, Battle of the VMs. So initially, maybe I can give a little bit of context about this fight. We had a nice blog post from Vitalik about simplifying the EL1, which suggested, okay, let's replace maybe the EVM by something else. Even if we saw yesterday that, yeah, the EVM can scale a lot, there are still debates about how it could scale. So we figured that, well, the best way to discuss what the replacement of the EVM will be, rather than doing, a lot of boring blog posts and technical topics, will be to have 3 people fighting in a ring, each one telling us what's the best about the VM that they built. So I think we only have ZK people in the room, but that's perfect, because then we can probably fight around ZK, and if someone wants to defend the EVM or another VM, please feel free to do so. So maybe I will start by, well, letting you introduce yourself. Sorry, you forgot to pick the mic, so I forgot to tell you so. So we have 2 mics, and 1 mic will be shared around the third contestant. And yeah, so maybe a few words about yourself, what you are doing, what is your battle going to be, and what you are going to fight for. So let's start with Alex over there.
Yep. So nice to meet you all. So yeah, I'm Alexandre. I'm working at Linea, and I'm leading the powdr team there. So, well, essentially, my role is focused around the ZK research and implementation of the proof system. But I also contribute a lot to the protocol design and the arithmetization of Linea.
Good morning, everybody. I'm Clément from Kakarot. So Kakarot, we have built, I think, 4 EVMs, 2 Kakarot VMs, and now another ZK EVM. So we have just an experience a bit in the topic.
Hi everyone, I'm Leo, work at Powdr. We work on ZK VMs, compilers, optimizations, and just making ZK VMs as fast as they can be from a compiler's perspective.
Okay, thank you. And yeah, maybe some little point I forgot to mention. So, well, just administrative stuff. We'll have to fire someone in the middle of the debate. So just to make things a little bit more spicy. So I hope you won't mind if you get fired in the middle. In the meantime, people don't forget to scan the QR and to get started, and maybe to get the ball rolling, you can say, okay, so what would you say you are doing differently, from the others, and what are you doing best? What are your best points? Weak points of your competitors? What are you thinking about all this? Why are you the best VM, basically, and why should you not leave the room in the next 10 minutes?
Yeah, so the first thing is that we are actually in production, so I think that's a strong point.
Yeah, that's a
very strong
point.
Plenty of VM projects, but yeah, that's very tremendous project, and that's, I believe, really hard from experience to go in production. So I think that's one fair point. Another thing is toward efficiency. So Linea EVM does not use ZK EVM. It's like directly constraints to EVM, and from that we can just squeeze as much efficiency as we can from it. And measuring the trace size, it's like 10x, 12x in terms of trace size, which is not, again, that we can have with a ZK VM. Like, you have to manually optimize everything to get it.
Yeah, but I don't think you have a VM, actually, do you? Because you just write circuits. So I don't know if you have your place here.
Yeah, so the VM is the EVM.
No, you have made circuits to prove the EVM.
Yeah,
you have not built an EVM
That's still
We're saying the same thing.
It's a VM for a EVM, so.
It's not a VM itself, is it?
It's not a general purpose VM.
Anyway, because we are debating if you prove the EVM, you are not building even an EVM, you are building a prover for the EVM. You are not like designing a VM, you are not you are not crafting a VM from
But you don't have to. It's a ZK VM implementation for the EVM.
Oh, it's a ZK VM for sure.
Yeah. I was not ready for that. Do you even belong there? I didn't expect that in the debate, but please go on.
No, as far as I understand, for example, if you work at powdr and you were saying that you were working at the compiler level to decide which opcode might be included or might not be included, or how you optimize the instruction set. This is crafting a VM.
Well, that's more
picking an EVM and proving the EVM. This is not crafting a VM.
No, but you don't have to craft it to implement it. They have a VM which supports the EVM. It's not a general purpose ZK VM.
It's still train
it's a
complete
VM.
in a way. But I'd argue that anyway the main use case for ZK is EVM, and I think that's why every ZK EVM project is competing in the L1 ZK EVM track.
I mean, I'm not saying this solution is not working for the EVM, for proving the EVM. I was just meaning the fact that it is not designing a new virtual machine.
But that's not what he claimed, though. He claimed
Yeah.
It's not the claim. It's not the claim. I thought it was sort of the debate here to discuss about.
Maybe I can clarify.
I think he was just describing what
VM, and I was saying, okay, anyway.
Yeah. Just to clarify, so it's EVM constraints, and there is no in-between layers. ZK VM in-between layer.
Okay, thank you. So I think we have addressed that point. We know that everybody can stay at least for the next 7 minutes. Maybe something else. I mean, maybe a question that everybody is asking, because if we want to replace the EVM, the first thing we would have to do would be to be able to prove the current EVM, or at least to offer the same functionalities as the current EVM. So where are we regarding that? So is it something that works already today? Is it something? Can we plug a replacement, for example, and say today we can run the actual contract, so we can at least have exactly the same experience? Where are you today regarding that?
So we are type 2 with a plan to go type 1. The main difference today is that we are, I believe, at London level. I want to be sure, but Pectra, we are going to be at Pectra level compatibility in September, and we target Fusaka for end of year and type 1 for mid next year. So currently, the UI is still pretty much the same. Only issues that our users have is that they have to use an earlier version of Solidity. So that's something we are aware of, and that's something we absolutely want to fix. The gap to be fully type 1 are those few EIPs that we have to implement. We need to migrate the state to have a Patricia Merkle tree, and then we will be able to have really apple-to-apple comparisons. Now, looking at the trace size, it's like 100 times better, but if you don't prove the Patricia Merkle tree, it's a little bit simpler that way. So it's not apple to apple. And there are a few precompiled that are just skipped. SHA-2 and RIPEMD, which nobody uses anymore, but that we still need to implement to be completely type 1.
Yes, for my side, despite the fact that we have actually spent lots of time building the EVM, I don't really believe it makes sense to keep building special purpose proven EVM. I mean, I'm much like in favor of, at least for now, the ZK EVM approach. Whatever instruction set is picked. I mean, I'm not saying that RISC-V needs to be picked. I think Vitalik opened the Pandora box and it was a good topic to. I mean, it was good to say it first, because we don't need all the time to just comply with whatever has been done. And with respect to this, I think that working with another instruction set for the base layer makes sense, and I think it makes sense to think about it. And then once it's picked, whatever it is it RISC-V or is it another one, then we can build the compatibility EVM so that everyone can run in compatibility mode. And this is sort of what we've done with. I mean, Cairo is not meant to be chosen for being the base instruction set for Ethereum, and I don't mind. But if it was chosen, say, then, for example, for us, we built in 4 months a full execution client in Cairo. So whatever instruction set can be picked, then we can build the full execution client. It's not even type 2 or type 1, it's just type 0. You just prove the new state root. This takes only 4 months. So I'm really in favor of picking an instruction set and then doing an EVM emulation inside it.
Yeah, I actually agree with a lot of Clément's side, and I think that actually works even for the EVM itself, which is like, you need to sort out what the priorities are, and then maybe the EVM itself doesn't even have to be changed. I think it's a good discussion to be had, but you don't necessarily have to change it. So after Vitalik's blog post, I actually wrote a blog post as well, kind of like not necessarily a counter blog post, but going through different ISAs and what it could look like for Ethereum. And I think right now it's even not clear what the priority should be. And when you know the priorities, then you know what ISA you want to go with. And even, RISC-V could be fine. I think RISC-V is used now by a lot of the ZK VMs because of convenience, because you just want to prove Rust, and RISC-V is the simplest ISA that gives you that can be implemented, but it's definitely not the most performant. So you could, if you want more performance, you could go with MIPS, for example, which you already see it with proofs that is very fast, or with WASM plus a smart compiler, which we are building right now. and eventually we'll see how much better, if at all, this is than RISC-V. But this all depends on what the priorities are. But if I personally had to pick something, also from the compatibility side, I think WASM really fits, because if you force smart contracts on the L1 to be RISC-V, it's really low level, so you don't have a lot of flexibility from that point on. You can likely get fast ZK proofs, but you can't do much else with it. You're kind of like stuck with it. It's a very low level model. Whereas if you have something higher level like WASM or even MIPS, then you can still do different optimizations on the ZK VM itself. You can have its own internal ISA with provable transpilation, and this can be a lot more performant and let you do different things and be future-proof as well, instead of just like locking into RISC-V forever on the smart contract layer.
Okay, so we're on the RISC-V versus not RISC-V. So my take on this is that the idea is here to solve two problems. Like, can we make the EVM more efficient? In that case, I agree that RISC-V is not the best choice, but it's a choice that might work. And it is also meant to simplify it. What I believe is that this type of ideas looks very simple at the beginning when there is no spec, and it looks incredibly complicated at the end once you take into account retrocompatibility, and so on, because the contracts that are already there has to keep existing. So in a way, it will never be RISC-V alone or just custom ISA alone. It's going to be ISA plus EVM. So I'm not too sure. I mean, maybe one spec is going to come out and it will actually work, but not very convinced about that. And about performances, I would say, yeah, I mean, if we care about performances, we should probably just simplify the EVM. Like, what came out in what is expensive in the EVM are the precompiled and the Ketchak. But then when I benchmark the EVM, that's not really what I see. I think it's more like 10% are precompiled stuff, and the rest is CPU.
That's odd though, because in all the profiling that we do with different teams, like signature and Ketchak is like 80% of the whole thing.
80%?
Yeah. So then the precompiles really they're fundamental for ZK VMs. Yes. Maybe in our case because you have direct implementation of the EVM. Yeah. But for general purpose ZK VMs without precompiles, you can't do anything for Ethereum.
Oh no, you do need the precompile though.
Yeah.
But what I saw is that if you look at the trace size at the end, with using precompiles, then you get maybe 5 billion cells for ECDSA.
Oh, with precompiles,
like that.
Right? Yeah.
Maybe the same thing for it's even maybe the same thing for Ketchak and 80 billion for the CPU and all the other stuff.
Right, but I think that's actually an argument even against RISC-V in a way, because you still need precompiles in the ZK VMs, right? So it's like, sure, you can claim that it's faster because you do native proofs for smart contracts in RISC-V, but you still need all the precompiles which inject a lot of security risks, and they're massive circuits that no one wants to read and audit and write. So the risk is still there, the work is still there. So I'm not fully claiming this, but one could argue that you don't get rid of precompiles, so why bother?
My point of view on this is, anyway, it's an expensive thing. The precompiles are expensive, and regardless of which ISA, or even if you do direct arithmetization, then everything is a precompiled in a way.
Exactly.
You have to address the performance problem, and you have to do the precompiles.
Yeah, so this could be turned into an argument pro EVM, that like, why change at all then if the whole implementation is relying on precompiles?
Yeah, I mean, implementing the precompiles is a very well-scoped thing, but for the general implementation of the EVM, I think we want something more automated. So it's a weak point actually for us, but we want to address that by switching everything to a language that compiles directly to constraints, a little bit like Noir, I believe. So that way we can write, for loops, this kind of functions, stuff like that, but still have direct constraints, so all the benefits of the EVM.
Well, I personally I don't think that it's a good idea to mix the need for ZK, like we want to prove the base layer, and the I would say the protocol thinking, like what actually do we want to have as developer to be able to run on the blockchain actually. So when you build the ZK EVM and you mix the ZK and the EVM itself, and I've built the EVM and now you say that you still are in troubles to catch up with the updates, I think even if you make it in 6 months, anyway, there is still this delay. You cannot be like real time. And building a client, making sure that you are 100% compliant, that you follow the 20K test, like from the Ethereum Foundation, for example. This is a whole work. I mean, building a client is a whole work. Building an efficient ZK system is a whole work in itself. And I think it's best to split them, just not to mix everything. And with respect to this, then you need to decide whatever instruction set is the best for this ZK task. And then you decide how you implement your client or what kind of compatibility you do with it. So I'm really in favor of changing the instruction set to make sure that we can fast verify proofs on the base layer, and then we can write whatever compatibility is required with whatever high-level language. And the performance, if it's too high in terms of performance drop in compatibility mode, then the developers will just change, I think, to rewrite in the optimized way.
Okay, we are in the middle of our debate now, so I think we have 10 minutes left. So question is, I'm supposed to fire someone. So well, how can we do that? I mean, can we do that by public vote? Because I realize that we can't vote with the application actually because we have 3 contestants. So I think we can do that with a show of hands, maybe. So who wants to keep Alex with us? That's nice. That's nice. So, who wants to fire you? And who wants to keep Leo? Oh. That's okay. So maybe I shouldn't have done it that way because it's a bit. So nobody wants to fire you. A bit less people maybe want to keep you than Leo, so I'm afraid, well, I will let you go. I'm sorry. I mean, no hard feelings. It was done by very confusing community vote. I hope. What? So, well, now we are back to fighting with 2 contestants. I hope I will still get my Linea allocation when the time comes, so yeah, sorry. And well, so we spoke a little bit about maybe performance, where we want to go, if we need to keep the EVM, or maybe if we just want to, well, if we couldn't just keep the EVM. And I think a good point is actually to define where we want to go, because that's not very clear. I mean, why are we doing all this? And in the end, even if we want to compute good performance, good benchmark, what actually is making a good benchmark in your opinion? Because I would say that, you know, it's a bit like when you have benchmark on GPUs. I mean, every manufacturer is going to come with a benchmark that's going to make its cards looks a little bit more shiny than the competition. So how do we as an ecosystem actually work on proper benchmarks, in your opinion?
I have liked the head-proof launch, to be fair, because the benchmark is not so clear, but as soon as there is an head-proof website, whoever is able to publish something every single block, on the long run, so it means that it's sustainable, financially speaking, then good for them, however they do it. I mean, if they manage just to publish the proof for a year, for 2 years, or 3 years, it makes sense to me.
I totally agree with that. I think benchmarking in ZK VMs has been very contentious and difficult because everyone is moving fast, and then it's difficult to integrate things, compare things, apples to apples. So I think ETH-Proofs has done a great job in that. And also to highlight projects that have great performance, for example, Kakarot and ZKM, for example, the MIPS, general purpose ZK VM, they do, are you guys on ETH-Proofs?
No, we
I don't think,
not,
but
we have had issues
benchmarks, and they looked really good, and ZKM is on ETH-Proofs, and they're highly competitive with like the big ZK VMs, the RISC-V ones, so to say, so I think they've done a really good job to. It's a single benchmark, so of course it's biased. Of course, everyone is over-optimized for a single application, which is Ethereum block verification. Doesn't necessarily mean that much for random use cases outside, but it is a very uniform case where people can, try to at least compete on the same arena.
Okay. Yeah. So everybody's agreeing on ETH-Proof, but I think it's a fairly new initiative, right? It's a couple months old.
6 months.
6 months.
Approximately, yes.
Yeah. And well, another thing that was interesting, I think, in the blog post that Vitalik mentioned is that, well, if we want to change something, we should be able to deliver an 100x experience. And I think that goes not just for performance, because that would be a little bit maybe restricting, but I would say for users and for developers as well. So how do you see that? How do you see that? Well, what would be the best VM and the best tool sets, the best toolkits, I mean, around it to achieve something like that? And is it even possible, in your opinion?
I think for that, if you want to have that as one of the priorities, I think WASM is the best candidate. Again, one could argue otherwise, because there used to be the eWASM approach, which was not picked up by Ethereum a couple of years ago. But times are different. We were not trying to have ZK Ethereum back then, and we are now. And WASM has great tooling, actually better tooling than RISC-V. It's more mature. It's used by a lot more people. And from a developer perspective, has more of like a sync with the application layer for Ethereum. So I think for that, if we're focusing on that, it was one of the big priorities. I think WASM is a good candidate.
I don't know WASM well enough, to be fair, to compete on this topic. No, yeah. And I think to add, I'm not sure about I mean, for sure, like saying, for example, what I know in terms of Cairo, for example, like the same user transaction in plain Cairo or emulated in the EVM running in Cairo, there is a 100x somehow in terms of number of cycles that are used, 50x. So it really makes sense to expose the base ZK native VM to the users. And I think if you do it, you get the 50x improvement. Yeah, possibly whatever ZK EVM actually.
Maybe regarding the experience for the developers, is it any choice that looks better in your opinion? For the developers, I mean, for people building the contracts, actually, is it a choice that you would put forward?
To use the base layer instead of Solidity plus EVM, you mean?
Yeah.
Yeah, I think that with a good tooling, the developers, they don't really. I mean, Solidity has been here. I mean, the tooling is here for Solidity now. But if you have ever used Viper, for example, Viper is not too bad. It's not Solidity. So why not building something else? I mean, there is now a new initiative for a Rust-like language also that sort of compiled to YUL as well, if I'm not mistaken. So I think developers can change.
I think, yeah, that would require these languages to build backends for whatever new ISA is used, because you can use, I mean, you could also claim that you want to use Rust smart contracts, which is fair enough, and I do think it can be good as well. But forcing that upon people, I think, would be a mistake, like from day one. I think this would take time. And there is already a huge network effect with both Solidity and Viper, and people would want to still continue using them. So, but yeah, I guess, yeah, in Vitalik's blog post, he does say that, yeah, these languages could just add backends, and I think they could. So Solidity actually used to have a WASM backend in the UWASM times, an experimental one that actually got removed when, yeah, the whole project was canceled. So I think, yeah, this should not be. And Matter Labs has the SolCX compiler, which takes YUL and goes through LLVM to EVM as well. So that could also be used to do RISC-V.
The experience of MATLAB is interesting as well. I mean, when you realize that they did first this compiler to compile Solidity to their custom ZK system for the initial era thing, and then what are they doing now? A RISC-V prover. So they've got all the knowledge for the very complex task of doing compiler level things to make sure that they can get the Solidity. And then now they do RISC-V and they are 10x better than all the competitors. So maybe they got a good knowledge when it was misused in too hard tasks. I don't know.
And maybe, so well, we are going to finish in 2 minutes. Maybe one point that we didn't look at the moment, something which is important as well, I think, is well, focusing on censorship resistance and the ability for everybody to be running nodes or to be even running provers. If we move to a world where everything is ZK, which is, I think, where we are going in the end. So in that case, what would be the best choice in your opinion?
If anyone needs to be able to run their own proof. So I'm actually saying a lot now, not your proof, not your coin. I think it's the new not your keys, not your coin. Because if everything is ZK and you need someone to prove your intention, you cannot like directly transact with the network. So it's an issue. So with respect to this, of course, the prover needs to be able to run on local devices. local devices. Might not, I mean, I'm full into mobile phone devices, but it's not strictly required that it be a mobile phone. Mobile phone have memory constraints that are another limitation. But yes, of course, people need to be able to generate proof, at least escape edge proof or something like that, like the minimal proof that can give you your asset back or something.
Yeah, I agree with that. I think we have to get to a point where you can generate proofs on at least your laptop, maybe not your phone, but at least a good laptop. And I think for that, from the VM perspective, you likely have to use some ZK-inspired ISA. So I think a combination of something high level and general purpose like RISC-V or WASM with something ZK optimized like Cairo, for example, which could be built at some point, could help give an extra 5-10x. That could potentially enable client-side proofs as well. Right now, very difficult to say. I mean, there's a lot of teams working on similar things, so I feel like this year and next year we'll have a lot of answers. And we'll be able to also decide what's priority, what's last priority based on what exists. I do agree with the general point. We need to be able to make local proofs as well.
Okay, but yeah, there are no blockers, I would say, today. One architecture that would be extremely better than the other, so basically one that would be completely discarded if we want to keep it on the censorship-resistant side.
I mean, there are already ZK DSLs and ZK VMs that allow for client-side proofs, right? You can use Cairo, you can use Noir, but then you wouldn't have the smart contracts you have now in Ethereum, right? So it's also a lot of high-level compiler work to bridge the gap from the high-level programs to the ZK proof, which is what not a lot of teams focus on right now, but I think there's a lot to do there as well. Like, the work has to be done, and once it's done, it's going to work.
Oh, okay, thank you.
So yes, I can say that I think that now that also there is a debate about which instruction set needs to be picked, while we know that at the prover level, with the modern prover, there is no real static instruction set that needs to be implemented. Like you can really opt in with new chips, new components. You pay only for what you use in terms of instruction as well. So you can imagine to have a big instruction set and also to have a reduced one. And maybe the compiler, depending on the provers that you have under the hood, if you want to prove on the GPU farms of someone else, then you are going to use lots of different chips. And then if you want to prove on your local devices, then you are going to compile with another target. And as you compile now with target, the same, but the prover on mobile might have been just the very limited number of instructions that are simple enough and you can optimize for mobile, for example. So yes, I think the debate about the instruction set actually is a bit too narrow because there is no need to fix actually something. I think we are just going to add instruction as we use them.
I agree. I think the ISA itself, from the prover side, it doesn't matter. You're just going to implement whatever is more performant for you internally, and it really doesn't matter. That's why I think the point is to stay flexible on the high level and then allow compilers to do the job of compiling or transpiling or whatever to whatever the ZK prover needs. And then you can say, oh, but then you need provable transpilation. Sure, then prove it. Like, we already have general purpose ZK VMs. You can prove transpilation once, and then have a snark for that, and then keep using the transpiled program to whatever is the optimized ZK ISA that the prover uses, and that's just going to work. So I agree with your point. I think the forcing an ISA for the prover, it doesn't really make sense. And yeah, sticking to it forever, it would be a mistake, in my opinion.
Sticking to what, sorry?
Sticking to like forcing a single ZK ISA onto all the provers, because now Ethereum uses that, would be very narrow-minded and premature, I think.
Yes. So if we agree, there is the.
In the end, we agree. Yeah.
In the end, I think it was supposed to be a clash. It's not really a clash. So I don't know. I mean, maybe the best. I mean, well, the only thing where we could get people to fight was to know if they really belong there. So no, I think that was already solved. I think in the end we agree that we are going to need to still to work a lot. I mean, to achieve better performance, and maybe even it can fit with the EVM. So yes, it was supposed to be a fight. It was not really something bloody, but I'm sure that it's going to get better with the next ones.
Maybe on crypto Twitter we will get more bloody.
Yeah. We're in person, we can't really fight.
Yeah. But on Twitter, that's always.
No, but this, I feel like, so 2 weeks ago in Berlin, there was an L1 interop workshop, and one of the sessions was on basically this. There was a couple like 10, 15 minutes discussing, shall we settle on an ISA for everyone to use? And there were people there also from ZK EVM teams, including teams that are more specific to RISC-V. And even those teams were saying, there's no need to force something onto everyone else. Like, yeah, we use RISC-V now, but we can change it anytime. And it was kind of a surprise that there was also no fight, and everyone was expecting like a big fight. And there were even more people there representing different ZK VMs, and there was no fight. So
so maybe that post on RISC-V.
I think it's too early. Maybe it will be RISC-V. Like, I think no one is also saying no, we will never be RISC-V. Maybe it will be, but I think it's just too early to make such a big decision.
Too early to pick the fight. Well, we will still be running Blockfighters next year, I think. So we can probably see if
we'll come back.
Yes, if we have more people to fight on. In the end, I think we can probably, since I will have to name a winner at some point. So even if I have still some time to go, I mean, I'm sure I will ask Jimmy to come, and he will be able to sing a nice song, and yeah, we will manage to keep the room. Full. So, how can we do that? I mean, we are going to fight on debates. I mean, we are going to fight on who made the best debate, maybe, or who made the best arguments, because we are not really going to be fighting on VMs. So let's make some noise for Clément. That's nice. I see you managed to take a lot of Kakarot friends, I mean, in the room. That's very good. And now let's make some noise for Leo. Yeah, hard to say. I would say I heard a little bit more creative noises for Clément, so I think I can just declare you the winner, and congrats. And next time you will bring more of your friends into the room. Yeah. So you are the winner of the non-debate. Congratulations. And you can shake hands because it was a good debate.
Thanks.
And don't forget to shake hands with the Linea, with Alex, because
it was to be
completely
something
belong there. Yeah,
nice.
please.